What's going on, everybody? My name is Carlton, aka Cisco Tutor, bringing you this awesome video on how you can configure a tunnel between two routers. Now, it's not just any tunnel between two routers, it's two routers where these routers are actually in home networks. So, for example, you may have a router at your home and your friend may have a router at his house, and you may want to configure a tunnel between them. So this video, guys, we're going to show you exactly how to do that. Be sure to like and subscribe to this video. You can also check me out on Instagram at Cisco Tutor. I plan on coming out with a lot more videos just like this, guys, to kind of get you guys up to speed on how to configure some of these technologies. So what exactly are we looking at right now? So I have a topology here where we're going to simulate how this would look in the real world. So if you're at your home, you're going to have this router right here that's labeled as R2. This is going to act like your modem. Now here where we have R1, this is going to act like the router where you're trying to configure your tunnel. And here you see we have R6. This router is going to resemble a PC in your network, so like your laptop, for example. Same thing over here, R4, this is the modem, but now we're at your friend's house. Router 5 is going to be the router at his house, and router 7 is just going to be a PC that's on his network. Now, router 3, this is just going to simulate the internet, okay? And then router 8 down here is going to simulate just the host on the internet. So what we're trying to accomplish here, guys, is this. We want router 6, which is your PC in this example, to be able to not only get to the internet, so we want to be able to reach this PC on the internet, which router 8 is resembling, but we also want to be able to ping router 7, which is the PC in your friend's network. Now, we already have a lot of things pre-built in this topology. We have network address translation already configured. If you don't understand network translation, I advise you to kind of get caught up to speed on that. I'm not going to go over it in this video because it's a lot to talk about, but I definitely will do a video about it in the future. But we already have network address translation set up, and what we're going to do is configure IPsec. So let's go ahead and start our topology here. And in this topology, guys, I'm using GNS3. So this is not on live equipment. This is one of the great advantages about learning Cisco because you don't need equipment. All my Cisco training that I've done, I've always used GNS3. You know how much it cost me, guys? $0. So right now we have the topology coming up. You can see over here, all of my routers are starting. So what we're now going to do is we're going to come to control and we're going to connect to all of our nodes. And when I do this, it's going to open the console session to all of my routers, which you can see they're popping up right now. Now, the first thing you want to do before you do anything is you always want to verify you have basic connectivity. There's no point in doing anything if devices can't reach each other. So let's go to router 6. I'm going to do a show IP interface brief because I want to see what IP addresses I have configured. I have this IP address right here, 10.10.16.6. What I want to verify is that I can reach R1, which is acting as my router in this example. So if I do a ping to 10.10.16.1, the first one was always going to fail, but as you can see, I have a success rate. So I can ping my gateway in this example. I want to do the same thing for router 7. I want to make sure I can at least ping my router, which is router 5 in this example. So I'm going to ping 10.10.57.5, and we should be successful, which we are. So that's great. Now, what I want to do is I want to make sure that my PC, which is router 6 in this example, can get out to the internet. So if everything is working, if network address translation is working, router 6 should be able to ping router 8, who is 38.38.38.8. So let's go to router 6 and let's ping him. We see that's successful, so that means network address translation is working. My PC can get out to the internet. Let's do the same thing for router 7. He should be able to get out to the internet as well. So we're going to do the same ping over to router 8. And it's successful, so everything is good. Now what we want to do is we want to configure the tunnel between router 1 and router 5 to allow 6 and 7 to communicate with each other. There's two ways you can do this, and I'm going to show you both ways. The first one is more complicated, but you still need to know about it. So all we're going to do is basically just configure an IPsec tunnel between R1 and R5. The first thing you want to do when you're configuring a IPsec tunnel is you have to configure phase 1, or what they call the ISACAMP policy. So let's do that. Now, IPsec is another topic. If you don't quite understand it, I would definitely recommend getting caught up to speed on it. That's another topic that I will make another video later about, but let's just show you guys how to set this up. So we're going to first go into configuration mode, and the command that you want to type is crypto ISACAMP policy, and we'll just give it a number of 10. So here's where we're going to configure all of our IKE phase 1 policies. What authentication we're going to use, what encryption we're going to use, what hashing algorithm are we going to use, and then what Diffie-Hellman group are we going to use. Let's do hashing. We're going to use MD5. For authentication, we're going to use a pre-shared key. For the Diffie-Hellman group, we're just going to pick 5. You have all these options here, but we're just going to pick 5 for this example. And for the which one am I missing? Hashing, authentication, group encryption. We're going to use AES, not triple dash, AES 256. So if we do a show run, pipe section crypto, this is our IKE phase 1 policy. Now, in order for this to work, it has to be the same on router 5. So all we're going to do is just copy this, and then we're going to paste it on router 5. So we're going to go into configuration mode and just paste it. So now we have our IKE phase 1 policy in place. Next thing we got to do is we have to configure the key, because we're using the pre-shared key right here. So let's do that on router 1. The command is going to be crypto ISACAMP key, and then the key we're going to use is Cisco, and now we have to say what is the address of the peer. Now, the address we're going to use, and this is where it can get tricky, we're not going to use this address right here. So if I go to router 5 and I do a show IP interface brief, this is not the IP address that we're going to use, because in a real world, this is a private IP address. It wouldn't be reachable. We need to use the address that this IP right here is getting natted to. So it's getting translated to this 34 address right here. So that's the address we need to use. Remember, we're in a home network, which is a private network, which means in order for us to get to the internet, we got to get translated. So we're not going to form the peer to the private IP address. We're forming the peer to the public IP address. So it's going to be 34.34.34.5. We're going to take the same command, and we're going to put it on router 5, except now the peer is going to be router 1. And he's getting translated to this address, this 23 address. So he's 23.23.23.1. So now IKE phase 1 is in place. Let's configure IKE phase 2, which is our transform set. So we're back on router 1. We're going to say crypto IPsec transform set. And here we're going to give it a name. Let's just keep it simple and say my set. So here is when we're going to, again, say what are we going to use for encryption and what are we going to use for hashing. Now, you can use AH, but nobody really uses AH. ESP is what everybody is using. So we're going to use ESP. We're going to use AES for the encryption. We're going to use 256. And then we're going to use ESP. We're going to use MD5 for the hashing. Now remember, this has to match on both ends. So we now need to go to router 5 and do the same thing. So now that we have our transform sets on both of them, we now have to configure what's known as the crypto ACL. This is basically going to say what traffic needs to go over the tunnel. So from router 1's perspective, anything that's sourced from this network, the 10.10.56, and is destined for the 10.10.57 needs to go over the tunnel. So let's configure that. We're going to say access list 100, permit IP 10.10.16.0. We're going to put our wildcard mask. Then we're going to put the 10.10.57.0 with our wildcard mask. Now we're going to do the same thing on router 5, except now the source is the 10.10.57 and the destination is the 10.10.56. Actually, that should be 16, not 56. So let me make sure I actually got that right. Okay, so this is wrong. This should actually say 16. Matter of fact, let me change that. That should say 16. Okay, so anything sourced from 10.10.57 going to 10.10.16. So let's do that on router 5. We're going to say access list 100, permit IP 10.10.57.0. We're going to put our wildcard mask. Then we're going to say 10.10.16.0, and we're going to put our wildcard mask. Now we have to configure the crypto map. So let's do that on router 1. And the command you're going to use is crypto map. And we're just going to call this my map, and we give it a sequence number of 1. And then you're going to use this command right here, the ipsec1-isocamp. So ipsec-isocamp. So now we have to configure up here, and then we have to tell it what access list that we're going to use, which is this one that we just created. We're going to say set peer. And remember, the peer is the public IP address that router 5 gets translated to, which is this 34 address, 34.34.34.5. Then have to tell it what transform set to use, which is the one we just configured, which is my set. So let's take that. And now we have to match the ACL we just created, which is right here. And we use this command, so match address 100. Now the crypto map is configured. So if I do a show run section crypto, this is our crypto map right here. I'm just going to copy this into Notepad because the only thing that's going to change on router 5 is the IP address or the peer address. So instead of it being router 5, it's going to be router 1. So we're just going to take this. We're going to go over to router 5 and we're going to paste it. So now that we got the crypto map, the last thing we need to do is we need to go to the interface and we need to apply the crypto map. So it's going to be applied to FA00 on both interfaces. Let's come to 5. We're going to say crypto map, my map, since that's the name of it. And we're going to go to router 1 and we're going to do the same thing. Under that interface, crypto map, my map. Now, there's one other thing we got to do in order for this to work, and this is very important. So right now, we have network address translation configured on router 1 that's allowing router 6 to be able to get to the internet. So if I go to router 1, and I do a show run section NAT, oops. Right now, he's basically saying that anything that's coming in on this interface right here is going to get translated. So if I do show access list 1, it says right here, permit any. So it's basically, this command is basically saying everything is getting translated. The problem you're going to run into is that when router 6 sends traffic to router 1 is going to translate it, but then he's not going to send it over the tunnel because it's not going to match the access list that we just created. So it's going to come in as 10.10.16.6. Router 1 is going to translate it to the 10.10.12.1, which is this interface right here. Then router 1 is going to say, well, let me look at the crypto map, but then it's not going to match because the source just got changed. So what we need to do on router 1 is basically say this. Anytime traffic is destined from this network and it's trying to reach this network, do not translate it. We do not want network address translation to happen, because if it does, the traffic is no longer going to match our crypto ACL and it's not going to work. So if I go to router 6 right now and I try to ping router 7, it's not going to work. So the way we fix this is we go to router 1, and we're going to create a new access list. This one's going to be an extended one. We're going to say access list 101, and we're going to do deny IP 10.10.16.0, put our wildcard mask in, and then 10.10.57.0 with our wildcard mask. What we're then going to do is get rid of this NAT statement right here. We're going to say yes. And then instead, what we're going to do is instead of using access list 1, which is permitting everything to get natted, we're going to use 101 because it's basically going to tell router 1, don't do NAT if the traffic is coming from this network to this network, but we can do NAT for everything else. So we're going to say FA0/0. And it's one thing I forgot. We're going to say access list 101, permit any IP, any. So if I do a show access list 101, this is our new access list that's tied to our NAT statement. So if I do a show run include NAT, this ACL right here, we're using in our access list. I need to do the same thing on router 5 now. So let's go to configuration mode. We're going to say access list 101. We're going to deny IP. It's going to come from the 10.10.57 network for anything going to the 10.10.16 network. We're then going to do access list 101 permit IP any. Next, let's do a show run section NAT so we can get our NAT statement, which is this guy right here. We're going to do a no to delete it, and then we're going to put it back in. IP source NAT inside, IP NAT inside source. Instead of using list 1, we're going to use list 101. And the interface is going to be FA0/0. So if I do a show access list 101, this is our ACL. Show run include NAT. This is where we're using this ACL and our NAT statement. So the way everything is set up right now, router 6 should be able to ping not only router 7, but router 8. This would mean that he can get out to the internet and he can also ping the PC at your friend's house, which means your tunnel is working. So let's see. So can I still get out to router 8? I can. Can I get out to router 7? I can. So right now, our IPsec tunnel is working. That's the first way you would configure your IPsec tunnel. Now you can see this one is a lot more complicated, and then you got to worry about NAT and what should be natted, what shouldn't be natted. The second way I'm about to show you guys is a lot simpler, and you're still creating a tunnel, except now you're going to do a GRE tunnel, and then you're going to put IPsec over that. So let's see how that works. Let's go to router 1. I'm going to take off the crypto map. I'm going to do the same thing on router 5. I'm going to get rid of the crypto map on that particular interface, that FA0/0. So right now, the crypto map is gone. You can see where it says ISACamp is off, so IPsec is turned off, which means router 6 is not going to be able to reach router 7 no more. First thing we want to do is we want to configure the tunnel, and we're going to do this on interface tunnel 0 on router 1. We're given an IP address of 192.168.115, well, not 115, but just 15.1. We're given a mask of 24. The tunnel source is going to be FA0/0, since this is the interface we're using to reach router 5. The tunnel destination, remember, is going to be the public IP that router 5 gets natted to, the 34 address. We're going to do the same thing on router 5. We're going to configure tunnel 0, give it an IP address of 192.168.15.1 with a 24-bit mask. The tunnel source is going to be FA0/0, which is this interface right here. And remember, the tunnel destination is going to be the IP address that router 1 is getting natted to, the 23 address. So if everything is working, I see the tunnel comes up. If everything is working, router 1 should be able to ping router 5 over the tunnel. So I'm pinging router 5's tunnel 0 address. So if I ping 192.168.15.5, and well, this is great. It's not working. So let's see if we can figure out what we did wrong. So we do a show run interface tunnel 0. Okay, that looks right. If I go to router 5 and I do a show run interface tunnel 0. Let's see, that looks good. Let me see. Can we ping 34.34.34.5? We can. So can we ping the tunnel? We cannot. So let's see if we can troubleshoot this and figure out what is going on. So we do a show run. Let's go back to show run interface tunnel. So we have our tunnel source. We have our tunnel destination 34.34.34.5. And we have 23.23.23.1. Let me check my NAT statement. It shouldn't make a difference. Let's check the mask too. Let's do this. Show IP route. So there's the tunnel. Let's come to 5 and do a show IP route. And there's the tunnel. Let's see, can I ping the tunnel itself? Oh, well, there's the problem. I just seen it. I just figured it out. So apparently I gave router 5 the wrong IP address. That will make it not work in any situation. So let's do this. IP address on router 5 should be 192.168.15.5, not 15.1. So we had an issue where we had duplicate IP addresses, which means it's never going to work. Now, if I come back to router 1, it should work. If I do a ping and it works. That's how you troubleshoot, guys. So I actually just gave you a troubleshooting lesson as well in this video. So the tunnel is up. And in order to get this to work, what we now have to do is do a routing protocol over the tunnel. So we can use a protocol like OSPF over the tunnel to where router 1 and router 5 will form an OSPF relationship over the tunnel. And then router 1 can advertise this network to router 5, and router 5 can advertise this network to router 1. So let's do that. So we're going to go to interface tunnel 0, and there's different ways you can do this. I prefer to do it this way. We can say IP OSPF 1 area 0, and then we're going to go to this interface, which is FA1/0, IP OSPF 1 area 0. Now that's one way you can do it. Another way you can do it is this. You can simply go to router OSPF 1 and put your network statement like 192.168.15.0. Put your wildcard mask and then area 0. You can also do network 10.10.57.0. Put your wildcard mask, area 0. We see that the OSPF neighborship came up right there. If I do a show IP route OSPF, I should be learning this network over here from router 1. I should be learning that network. So if I go to router 5, notice that I'm learning this network. Just like if I go to router 1, I should be learning the other network from router 5. So now that we have the tunnel in place, router 6 should be able to ping router 7, which it can. But the problem that we run into is that traffic, when it goes over a GRE tunnel, is not secure. What I mean by this is if somebody has a packet sniffer, like let's just say we want to capture traffic as it's leaving router 2 going to router 3. And we're going to do this with Wireshark. So if I go back to router 6 and I do that ping again, notice I can see all of this traffic that just came up. And notice that it's in clear text. So I can see that it's coming from 23.23.23.1 going here. I can see that you're doing GRE, and I can see that it was an ICMP packet. I can see everything because it's in clear text. So if I have a tunnel between my home network and my friend's home network, and I'm using the GRE tunnel, I still want it to be secure. So that's when we're going to turn IPsec on now, so that we can make this secure. And I'll show you guys how that looks after we configure it. So now let's go back to router 1. We're going to, and this one is really simple. All you have to do, we already have our IKE phase 1 policy set. All you have to do is just create the transform set. There's no crypto ACL, there's no crypto map, because when you apply your IPsec profile that we're going to create, when you apply it to the tunnel, everything that goes over that tunnel is going to be encrypted. So you don't have to create an ACL to match against specific traffic. So we're going to create our crypto IPsec transform set. We'll call this one IPsec, and we'll use the same parameters as before, ESP AES 256 and ESP MD5. We're going to take this command, we're going to put the same thing on router 5. Now, this next command is very important, because if you don't put this command in and you do IPsec over GRE, it won't be successful. We have to say mode transport. We have to do this on both of them. And if you have any questions, guys, about that, feel free to reach out to me and I can go over that with you guys. But we have to say mode transport. So now that we have our transform set, let's now configure our IPsec profile. So we're going to say crypto IPsec profile. We'll just name this one my profile. Now here, all we're doing is telling it what transform set to use, which is the one we just created. So set transform set IPsec. And we're going to do the same thing on router 5. Let's come to router 5, set transform set IPsec. Now, the last thing, guys, to make this thing work and bring out all the magic is to go to the tunnel interface and do this command, tunnel protection IPsec profile, and then you put the name of the profile you just created. Notice that ISACEMP is now on router 1, so that's good. We now need to do the same thing on router 5. Notice that ISACEMP is now on for router 5, which means IPsec is now turned on. So now if I go from router 6, if everything is in place, router 6 should still be able to get to the internet, which is router 8, and I should still be able to ping router 7, which is the PC, or is acting like the PC in my friend's home network. So let's see. Can I get to 38.38.38.8, which is router 8? Yes, I can. Can I get to router 7? Yes, I can. And guys, that's it. Now let me show you exactly what it looks like when it's getting encrypted. So this is what it looks like when it's not encrypted. You can tell everything that I'm sending because it's plain text. Let's watch the traffic as it's leaving router 3 going to router 4. I'm going to right click and I'm going to go to start capture. It opens up Wireshark. Now I'm going to go back to router 6 and I'm going to do the ping again. You notice anything different? Notice that this protocol says ESP because now everything is being encrypted. So if you were to get all of this and you look at it, you're not going to have no idea what I'm sending. And this is how you want it to be. If you're going over the internet, you want everything to be secure. You don't want some hacker to get this information and now he knows your passwords or he knows whatever data that you're sending between your friend and you. You don't want them to do that. So guys, what did we do in this video? I showed you guys how to configure an IPsec tunnel 2 ways. I showed you guys how to do it where you create the crypto map and you apply it to these interfaces here and here. And we also did it over a GRE tunnel. But the magic that made this work, or the reason why I did it this way, because I wanted to show you guys how you would do it when you have a router that's in your private network and then your friend has a router in his private network. Because typically when you're configuring site-to-site tunnels, you're going to be doing it with, for example, router 2 and router 4, who already have IP addresses that are reachable over the internet. But in this example, you're trying to do it between router 1 and router 5, who if they had IP addresses in these IP spaces, they would not already have addresses reachable over the internet. So I wanted to show you guys how that worked. If you like this video, guys, please be sure to like and subscribe to it and be on the lookout for future videos that I do in the future. Hope you guys enjoyed it.